Hello friends, welcome. One of the applications of derivatives is to find out the intervals in which a particular function is increasing or decreasing. So, before knowing about how we can apply the derivatives to know the increasing and decreasing intervals in which the function is increasing or decreasing, let's try to step a little bit back and understand what is the increasing function or what is the decreasing function in a particular specific interval. So for that, we will try to observe the graphs of three functions here. I have three functions with me. So one is y equal to 2x plus 3. The other one is y equal to minus 3x plus 4. And I have y equal to minus x square plus 4. Now let's try to draw the graphs of this and see actually what are the silent features. We know y equal to 2x plus 3 is a straight line, we know that, and we know that at x equal to 0 y equal to 3, and we also know that y equal to 0 at x equal to minus 1.5. So that's a straight line we have. That is a straight line we have for y equal to 2x plus 3, and what we observe now is, as we are moving in the positive direction of x-axis, the values of the function are going on increasing. That means we are saying that if x1 is less than x2, then f of x1 is less than f of x2. So that is the observation we have. We can see that the slope of this is, y equal to mx plus c, the slope is 2. So we know that as we are moving in the positive direction of x-axis, or we are moving from left to right, the function values are going on increasing. So this is called as a increasing function, and you can see that this function is increasing for all the values of r. So you can say that this is an increasing function. Now let's look at what is the graph of y equal to minus 3x plus 4. For that I will take again x-axis and y-axis. We know that y equal to minus 3x plus 4 is a straight line with a slope of minus 3 and the intercept at 0, 4. So let us say at x equal to 0, y equal to 4, and y will be 0 when x equal to 4 by 3. So let me say that is the point we have. So if you try to join this, now you can see that as we are moving in positive direction of x-axis, suppose I have x1 and x2, this is x1 and this is x2, such that x1 is less than x2, then you can observe that as we are moving in the x2 direction, the values of the function are going on decreasing. That means f of x1 is greater than f of x2. So this function is called as decreasing function. And you can see that the function y equal to minus 3x plus 4 is a decreasing function for all the values of r. Similarly, y equal to 2x plus 3 is a function which is increasing for all the values of r. And remember, the slope is here 2 and the slope is here minus 3. Okay, we'll come back to that. Now let's go to this function which we have, y equal to minus x square plus 4. If this is a function, let's try to see how to plot that. We will have at x equal to 0, y equal to 4. So the function will be like that. And when y equal to 0, x square is 4. So x equal to minus 2 or x equal to plus 2. So the y value will be 0, and you know that it's basically a parabola, x square equal to 4ay. So the parabola will be like that. So that is how the parabola will be. Now, if you try to observe this function, whatever we are saying, you see that from the values, if you move from left to right in the interval where x is less than 0, you see that the function values are going on increasing. That means you see that as you are moving towards from you are moving towards the positive direction of x-axis or from left to right, you see that the function values are going on increasing. That means in this interval x less than 0, it's an increasing function. We know that by now. And similarly, look from here where x is greater than 0. When x is greater than 0, you see that the function values are going on decreasing as you are moving in the positive direction of x-axis. That means in the interval where you have x greater than 0, or can I say 0 comma infinity, or can I say here minus infinity comma 0, you see that x greater than 0, the function is decreasing. Now let us try to understand how the slope of any tangent to the curve at a particular point in the first part what we have considered. You will see that the slope is positive, and in the second part we see that the slope is negative. So by this understanding we can say very clearly that if you want to tell a function is increasing or decreasing, you have two options. One, we can draw the graph and we can see whether when I move into the positive direction of x-axis, whether the values of the function are consistently increasing or they are consistently decreasing, or we say strictly increasing or decreasing. What's the difference between strictly? When I say strictly, it is f of x1 less than f of x2. If I say just increasing, then equal to is also okay. I can have f of x1 less than f of x less than or equal to f of x2, then it is increasing. So this is actually strictly increasing. Similarly, this is strictly decreasing. And if you observe also, whenever we see the function is increasing in an interval, we see that the slope is positive, and whenever the function is decreasing, the slope is negative. So to understand whether a function is increasing or decreasing, one, we can draw the graph, we can observe the graph, and we can see how the slope is. And second way how we can do, if we don't want to draw the graph, is we can find out the derivative of the function, and we can equate the derivative to 0 and find out the intervals in which the function is increasing or decreasing. In other ways, we can say that if you are able to find out the derivative of the function and see that f dash x is greater than 0, f dash x is greater than 0, then it is an increasing function. F dash x is less than 0, then it is a decreasing function. So in this interval you can say f dash x is greater than 0, and in the second interval we know that f dash x is less than 0. So this way of finding out what are the intervals in which a function is increasing or decreasing is called as first derivative test, because we are applying the derivative and we are finding out the sign of the derivative. If the derivative is positive, then the function is increasing. If the derivative is negative, basically geometrically if you talk about the slope, you know that one of why we have differentiation, one of the reasons why they have worked so much on differentiation is to find out the slope of tangent to a curve at a particular point. Now if you see here in this curve, any point I take and draw the slope, you will see the slope is always positive of the tangent. Similarly, in the secondary interval, that's between 0 and infinity, you will see that the slope of the tangent to the curve at any particular point is negative. So to find out whether a function is increasing or decreasing, I can just look at the derivative of the function in that particular interval and see whether it is positive or negative. Now let's try to look at some simple examples and see how we can apply the concept. let's look at this example. Prove that the function f of x equal to 4x plus 7 is strictly increasing for all the values of r or on the throughout the real number line, strictly increasing. Now how to prove this? Now what we will say here, we will say first that x1 is less than x2. What is the meaning of that? I am moving from left to right. Now how to say whether a function is increasing or decreasing? When I move from left to right, I should have f of x1 less than f of x2. Now what we will do, we know f of x1 is less than x2. How I can convert this into f of x1 less than f of x2 so that I can say the function is increasing in that particular interval. So I have been given x1 less than, suppose I say x1 is less than x2, then you can say that there are 2 points. Then first, can I multiply with 4 on both the sides? Can I say 4x1 is less than 4x2? Now, you know that I can add or subtract on both the sides. So I'll try to add 7. I can say 4x1 plus 7 is less than 4x2 plus 7. Now if you observe, this is nothing but f of x1 and this is f of x2. So we have proven that f of x1 is less than f of x2 if x1 is less than x2. So what's the meaning of that? The meaning of that is the function is increasing, or if you want to cross check that, draw the graph of 4x plus 7. You can see coordinate geometry y equal to mx plus b or mx plus c, where slope is m is 4, positive slope. Positive slope, or you can find out the derivative of this function, dy by dx is equal to 4. dy by dx, nothing but equal to slope, is equal to 4. So positive slope or derivative is positive, then it is a increasing function in that particular interval. Now here we can see for all the values of r, this function is an increasing function. Let's try to do some more examples. Look at this. We have to find out the interval in which the function is increasing or decreasing. I just kept it like that. First let's write down what is the function we have been given. We know f of x is equal to 6 minus 9x minus x square. One option is we can draw the graph of this, we can find out we can plot the graph and we can see the values. But the other way, what we will do is we'll find out what is the derivative of that. F dash x is equal to minus 9 minus 2x. Now we will equate this to 0 so that we can find out the point, how we can divide this total real number line into the intervals. So we know minus 9 minus 2x, can I say 9 plus 2x is equal to 0, or 2x is equal to minus 9. That means x equal to minus 9 by 2. We know that this function is a continuous function and it's not having any breaks, and we see that at x equal to minus 9 by 2 the slope is becoming 0. That means, what is the meaning of that? The function is increasing in one interval and decreasing in the other interval. That's why we have the slope of the function at minus 9 by 2 is equal to 0. So this will divide the number line into two parts. We have minus infinity and we have infinity. This is the real number line, and we have a point that is minus 9 by 2. Now we have to find out the slope minus 9 minus 2x, how it is in the first interval and the second interval. We will check for, suppose let us say x equal to minus 5 here, and we will check for x equal to 0 here. If I check here, I have f dash x is equal to minus 9 minus 0, that's equal to minus 9. So the slope is negative, that means this is an decreasing interval, the interval in which the function is decreasing. Now let's look at, obviously the other one should be increasing, but we will try to prove it. For that, what we will do, we will take the value of minus 5. We'll have f dash x is equal to minus 9 minus 2 into minus 5 are nothing but minus 9 plus 10, that's equal to 1. So slope is positive or derivative is positive. F dash x is greater than 0. Here it is less than 0. Here it is greater than 0. When it is greater than 0, it is increasing function. So my answer will be the interval in which the function is increasing is minus infinity to minus 9 by 2, and the interval in which the function is decreasing is minus 9 by 2 to infinity. So if x is less than minus 9 by 2, then the function is strictly increasing, and it's strictly decreasing for x greater than minus 9 by 2. We'll do one more example and wrap this session, and we'll continue some more examples in the coming sessions. Let's look at this example. We have been given, find the interval in which this function f of x is minus 2x cube minus 9x square minus 12x plus 1 is increasing or decreasing. So what we will do, first we'll write down f of x is equal to minus 2x cube minus 9x square minus 12x plus 1. Now f dash x, we'll do the first derivative test. So we'll apply the derivative. It's minus 6x square minus 18x minus 12. We will equate f dash x to 0 so that we can find out the point where the derivative is 0 or the slope is 0. Now this makes it minus 6x square minus 18x minus 12 is equal to 0. Can I say minus 6 into x square plus 3x plus 2 equal to 0? Or can I say minus 6 into x plus 1 into x plus 2 is equal to 0? Minus 6 into x plus 1 into x plus 2 is equal to 0. That means, what's the meaning of that? At x equal to minus 1, comma, at x equal to minus 2, the function derivative is becoming 0, or the slope of the curve becomes 0. Now let's try to divide the number line according to this. I have first minus infinity, I have infinity here. In between I have minus 2, this is minus 2, and I have minus 1, this is minus 1. So let us see in each interval how this function varies, whether it is increasing or decreasing. First we will consider, we know that, what we know, f dash x is equal to minus 6 into x plus 1 into x plus 2. Now let's start from left to right. We will take first an point between minus infinity to minus 2. Let me take x equal to minus 3. What happens? Minus 6 into minus 3 plus 1 minus 2 into minus 3 plus 2, that is again minus 1, and you see that you have negative, slope is negative. That means the function is decreasing in this interval. Now let's go to the second interval we have between minus 2 and minus 1. So we will put x equal to minus 1.5 there, which is there between minus 1 and minus 2. If I substitute, I'll have minus 6 into 1 minus 0.5 minus 1.5, that is minus 0.5 into 2 minus 1.5, that is 0.5. So you have minus into minus plus. We have positive sign here. That means the function is increasing between the interval minus 2 to minus 1. Obviously on the other side it will be decreasing, but we will check for x equal to 0. If I put x equal to 0, I will have 0 plus 1 1 and 0 plus 2 2. 1 into 2, 2 into minus 6 is minus 12. So the function is decreasing in the intervals minus infinity to minus 2 and minus 1 to infinity, and the function is also increasing in the interval, strictly increasing in the interval minus 2 comma minus 1, open interval. So we'll try to do some more examples applying the concept. To summarize, one of the application of derivatives is to find out the intervals in which a function is increasing or decreasing. To know whether a function is increasing or decreasing, we'll find out the derivative of the function, and we'll try to find out the intervals in which the derivative is positive or negative. If the derivative is positive, then in that for all the values of the interval, then in that interval the function is increasing. If the derivative is negative or less than 0, then the function is decreasing for all the values in that particular interval. So I'll catch you again with some more examples as part of the same topic, that is increasing and decreasing functions, applications of derivatives. Thanks for your time and support. Bye for now.